Measurement of the time. How we can measure the time? We have seen this if you are going to measure the time, then which devices are basically used for that measurement. So stopwatch and the stop clocks are basically used when you are going to measure very small interval of time such as few seconds or few minutes. You can see here a stopwatch is shown and it has the analog display. This one, it has an analog display and there is a needle that is moving into the circular path. So some stopwatches have basically the analog display with the needle that moves around a circular scale. So how you can define the stopwatch? Stopwatch is a handheld timepiece designed to measure the small amount of time that elapses between its activation and deactivation. So it is a stopwatch. Stopwatch is basically the small handheld timepiece and it is used to measure the time that elapses between the activation when you start this stopwatch and deactivation means that when you stop this stopwatch, then the time that elapses between this is basically the measurement of the time that is taken by the stopwatch. So there is a large digital version of the stopwatch designed for the viewing at a distance, such as you can see in the sports stadium. It is basically called as stop clock. So I can simply say that when you are going to take the measurement of the time, then you can use two devices, stopwatch and stop clocks. A stopwatch has digital as well as analog display. Both of these are basically used for the measurement of the time. If I suppose that you are going to find out the correct and the accurate measurement of the time, then how you can measure it? Now we will see it, the accurate measurement of the time. Sometimes the stopwatch and the stop clocks does not give us the correct and the accurate measurement of the time. In this case, what you need to do? So when you have to make the accurate measurement of the time, you can see here our device, which is basically used to measure the accurate time. It is called as simple pendulum. So how you can measure the time with the help of simple pendulum? First of all, there are different parts of that pendulum. There is a very rigid spot with which a string is attached, and this string should be very light. There is a mass which is attached to that string. This whole becomes as pendulum. The solid line that you can see here, it is basically the string and this mass. Both of these combines to give a pendulum. This mass sometimes called as bob. Then what you need to do, this is the mean position or the equilibrium position in this case or the rest position. Then suppose that you bring this mass on the other side like on some extreme position here. Then this mass does not stay here, but it moves towards the mean position. In this direction, at this position, it also does not stop, but moves towards the other extreme position. And then moves back towards the mean position. In this case, the simple pendulum will oscillate about its mean position. So, the time taken by the simple pendulum to complete one swing or one vibration is basically called as time period. We can easily find out the time period of the simple pendulum. So first of all, you have to know about what is a swing or oscillation or vibration. So, if I say that the body starts from the mean position, it goes towards the first extreme position, then come back to the mean position, again goes towards the other extreme position, and then come back again to the mean position. This basically the whole journey is called as one complete swing, which is also given here. One complete swing or the oscillation or vibration, all of these are same terms. So from here, you can simply say that time period is a time that is taken by the pendulum to complete one complete swing. We need to find out that time period, which is basically time. So here it is given that the string and the both of these combine to give the pendulum. Going back, so when you are going to find out the accurate measurement of the short interval of time, what you need to do? You have to take the lots of measurement, like you just take a large number of values and then divide that value with the total number of values to get the correct measurement of the time. So I can write here time is equal to large number of readings. Just you need to take the sum of these readings divided by total number of these readings. You just need to divide both of these to find out the accurate measurement of the time. So here is an example, measuring the time period of the simple pendulum. How you can find out the time period of the simple pendulum? Suppose that the pendulum takes 2 seconds to complete one swing. So if the pendulum takes 2 seconds to complete one swing, then what would be the time period? Of course, it would be 2 seconds. Time period is equals to 2 seconds because 2 seconds is the time that is taken by the pendulum to complete one complete swing. So basically it's given here, suppose that the pendulum takes 2 seconds to complete one swing, provided that the swings are very small and each swing takes the same amount of time. This is basically referred as time period. Next, you need to measure the time for the 20 swing. Suppose that the time for the 20 swings is 44 seconds. And then divide this 44 seconds with the total number of swings to find out the accurate time period. Measure the time for the 20 swing. Suppose that you are just going to calculate the 20 swings. Measure the time for that and then divide it with 20 to get an accurate measurement of the time period. Let the average time for the 20 swings is equals to 44 seconds. Then what would be the time for the one swing? It would of course 44 divided by 20, which is 2.2 seconds. So this 2.2 seconds is basically the time for one swing, which is time period. So I can simply say that the time period of the simple pendulum is 2.2 seconds. So if I ask a question from you, if I suppose that the pendulum takes total 30 vibrations or swings in 55 seconds, then what would be time period in this case? You need to find out the time period. Again, the same slide that is related with the simple pendulum. Here in this slide, simple pendulum as well as one complete swing and the time period you can understand easily. So there is a simulation related to simple pendulum lab. Here you can see that there is a pendulum which is mentioned here 1. It is basically the mean position or the equilibrium position. There is a ruler which is basically used to measure the length of that pendulum. Stopwatch you can also use to when you are going to measure the time period, and you can also take the periodic trace, the path that the pendulum will follow. So here we will see that what would be the effect on the time period of the simple pendulum when you changes the length, mass and the value of the gravity. So let's suppose here initially the length is 0.70 meter. I decreases it. No, the length is half, 0.50. And the mass is again 1.00 kilogram. Gravity is normal. Then if I start its motion, what will happen in this case? So the time that is taken by that pendulum to complete one swing is basically the time period. Now what would be the effect by changing the length? Here you can see I increases the length from 0.50 to 0.90 meter. Then this pendulum swings very slowly. It means that it takes more time to complete one vibration. So I can simply say that by increasing the length, the time period also increase, because the pendulum takes more time to complete one swing. So I can simply say that the time period and the length, both of these are proportional to each other. By increasing the length of the pendulum, the time period also increase. Now if I decrease the length of that pendulum, then what will happen? You can see it's oscillating very quickly. It means that this pendulum takes very small time to complete this vibration. Means that by decreasing the length, the time period also decrease. If I fix the length 0.50 meter, and now I am going to change the mass to see the effect of changing mass on the time period of the pendulum. Initially the time period is affected by the length, but now the length is fixed. The mass is 1.00. So if I take the mass here 0.50 kilogram, then see the time period. Now if I increase the mass, there is no effect on the time period. It remains the same because the pendulum takes the same time to complete one swing. The time period is independent from the mass. There is no effect of changing the mass on the time period of the simple pendulum. Next we see the effect of gravity. If I fix the mass also at 0.50 kilogram, and now I am going to change the gravity. Initially the value of the gravity is normal, which is 9.8 meter per second square. Now I will increase the gravity. Then what will happen? By increasing the gravity, the time period decrease. You can see in this figure. So in this case, you can just see the effect of changing length, mass and gravity on the time period of the simple pendulum. Here we see the direction of the velocity and acceleration from here. The direction of the velocity is shown by the green arrow, while the acceleration is shown with the yellow arrow. So if I again start the pendulum motion, see, yellow arrow is always towards the mean position. What does this mean? It means that the acceleration is always directed towards the mean position, and the velocity changes as the pendulum vibrates. It depends upon the motion of the pendulum. Again you can change here the masses as well, and the length and gravity, and see the effect of all of these changing on the time period of the simple pendulum. Here is also the stopwatch that is used to measure the time period. In this case, if I start it again, put here the stopwatch and bring the pendulum to some extreme position. You just need to count the time period for one swing. How much time taken by the pendulum to complete one swing. So let's start its motion from the extreme position. Also by starting the simple pendulum motion, I start the stopwatch. The time taken by the pendulum to complete one vibration is basically 1 and 56. It means that it's almost very small time that is taken by this pendulum to complete one vibration. So the time period is very small. That's why when you have to make the accurate measurement of the time period, you have to divide it with the total number of vibrations. This is also available in your account. You can practice from here. Going back to PPT. There is a question that appeared in May-June 21, 2020. A pendulum makes 50 complete swings in 2 minutes 40 seconds. What is the time period for one complete swing? So here basically the total number of swings are given, which are 50. And the time for that is also given. Time is 2 minutes and 40 seconds. First of all, you need to convert the time into seconds. As you know that in 1 minute there are 60 seconds. So there will be 2 times 60. 2 minutes convert into seconds plus 40. It would be equals to 160 seconds. So the total number of swings are 50 and the time taken to complete that swing is basically 160 seconds. What is the time period for one swing? You need to calculate the time period. Option A 1.60, B 3.2 second, C 4.8 second, D 6.4 second. So when you have to find out the time period, just divide the total number of swings with the time that is taken to complete that swings. Here is answer and explanation. The total number of swings are 50. Total time is 2 minutes 40 seconds, which is basically 160 seconds. So the average time for 50 swings is basically 160 seconds. Time for one swing is equals to 160 divided by 50. So you get 3.2 seconds. This would be the time period in this case. Therefore, the time period is equals to 3.2 seconds. So 3.2 seconds is given in the option B. Hence, from here the option B is correct answer.